Hello grade 12s and welcome to another chemistry lesson. So we're still dealing with organic molecular structures. This is the second segment, okay? Now some background information that you need to know is that structural isomers are organic molecules with the same molecular formula but with different structural formulae. Chain isomers are organic molecules with the same molecular formula but different types of chains. For example, hexane and trimethylpentane. So these are both alkanes, but as long as there starts to be a branch, you understand, for example, a methyl group, that's when you know that they are chain isomers. Functional isomers are organic molecules with the same molecular formula, but different functional groups. For example, aldehydes and ketones. So you know that aldehydes and ketones have this general formula, CnH2nO. Right. Other examples of functional isomers are esters and carboxylic acids. Positional isomers are organic molecules with the same molecular formula but different positions of the side chain, substituents, or functional groups on the parent chain. For example, butane 1-ol and butane 2-ol. The alcohol, the hydroxyl group, is in different position. Alright, I hope that made sense. Please take this down. I modified it from the Western Cape Government Educational Guidelines. Number 1 states, give the term that best fits the following descriptions. A molecule containing carbon atoms. Now, any molecule that contains carbon atoms is called an organic molecule. (1.2) A series of organic compounds that can be described by the same general formula, that is called a homologous series. (1.3) Organic compounds that consist of carbon and hydrogen only, those are called hydrocarbons. (1.4) A bond or an atom or a group of atoms that determines the physical and chemical properties of a group of organic compounds. That bond or the group of atoms is called a functional group. Okay. Number 2 states, give the name of the homologous series described by the following functional groups. Roman numeral number 1, only carbon-carbon and carbon-hydrogen single bonds. Carbon-carbon and carbon-hydrogen single bonds is alkanes. Roman numeral number 2, at least one carbon-carbon double bond. Remember, when you have one carbon-carbon double bond, it's an alkene. Alkene or alkenes. Roman numeral number 3, at least one carbon-carbon triple bond. Carbon to carbon triple bond is an alkyne. These are the primary hydrocarbons for grade 12. Roman numeral number 4, halogen atom bonded to a saturated carbon atom. Halogen atom saturated, this is a haloalkane. Sometimes called the alkyl halides. Roman numeral number 5, hydroxyl group bonded to a saturated carbon atom, then it's an alcohol. Alcohol or alcohols. Roman numeral number 6, formyl group or carbonyl group bonded to a carbon atom and a hydrogen atom. Formyl, remember, aldehydes. Roman numeral number 7, carbonyl group bonded to two carbon atoms. When you have a carbonyl group, you're dealing with the ketones. Roman numeral number 8, carboxyl group. Remember, when you have a carboxyl group at the beginning of the chain, you're dealing with the carboxylic acids. Okay, I hope that makes sense. There's an R here. Carboxylic acids. Number 3 states, give the names of the following compounds and then state the types of isomers they are to each other. 3.1, you have that compound 1, then compound 2. So let's start with compound 1. As we can see, it's saturated, right? Carbon, 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 carbon. Hydrogen, 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 bromine, hydrogen, hydrogen. So, bromine, right? We have to name from this side 1, 2, 3, 4, 5. So in position number 2 we have a bromine. So this is 2 bromo. How many carbon atoms? 5. Pentane. Then compound 2, hydrogen, hydrogen, bromine, hydrogen, 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 5 carbons. If we start from here 3, here 3. So 1, 2, 3, 4, 5. The bromine is in position 3. So this is 3 bromo pentane. 3 bromo pentane. Therefore, these are, remember the functional group is in different positions, so these are positional isomers. Compound 1, you have that. Compound 2, you have that. So we have to name compound 1. We have double carbon atom bonded to an oxygen. Okay, so we start here. This is a formyl group. Okay, or you can say it's a carbonyl group bonded to a hydrogen and a carbon. So formyl group is an aldehyde. 5, so it's pentanal. Compound 2, the carbonyl group is in the middle, it's not at the beginning. So we see if we label from here 1, 2, 3, 1, 2, 3. So it's the same. So this is pent 5, but the carbonyl group in the middle is a ketone. So pentan 3 O. Okay, pentan 3 O, pentanal and pentyl 3 O, aldehyde ketone. So therefore these are functional isomers. I hope that is clear and I hope that makes sense. 3.3, compound 1, we have that. Compound 2, we have that. So by looking at it, we can already notice a triple bond. If we start here, 1, 2, 3, here 1, 2, 3. So 2, 3, 4, 5, 6. And then we have this triple carbon-carbon bond. Okay, so compound 1 is triple carbon-carbon bond alkyne. Okay, 6, so hex. Hex 3 I or 3 hexine, whichever way you prefer to name it. 2, triple carbon-carbon bond We have to start here because this is the closest. 1, 2, 3, 4, 5, 6. So this is hex 1-ine or 1-hexyne. Okay. They are both alkynes. It's just the position of the triple bond. So these are positional isomers. I hope that makes sense and I hope that's clear. 3.4, compound 1, you have that. Compound 2, you have that. Okay, so compound 1, saturated as we can see. 5 carbons, 12 hydrogens. So compound 1 is pentane. Compound 2, we have branching. 1, 2, 3, 4, 5. 5 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. Now we need to get to the IUPAC naming. 1, 2, 3, 1, 2, 3. Either way, whichever way we do it. 1, 2, 3. So you have 2 methyl groups in position number 2. The longest chain is 3 carbon atoms. So this is 2.2 dimethyl meth eth pop. So dimethyl propane. Ane. But here there's branching. So therefore what are these? These are chain isomers. When you get to varsity, you have iso, neo, and I forgot the other group. Okay? But that's how it is. I hope that was clear and I hope that made sense. Keep practicing until you get it. This is what you should expect from part 3. If you found this video helpful in any way, please click the like button and subscribe for more content. Thank you very much, and I hope to see you again.